So today we're going to talk about the reciprocal function, which is the most basic rational function. All right, it is in the form of f of x is equal to 1 over x. This is different from any other function we've seen because now our variable is in the denominator of a fraction. That actually is going to introduce some restrictions that we'll talk about later. And remember, f of x is just function notation. It just means y. So y equals 1 over x is also what this is talking about as well. Okay. I told you yesterday that you didn't have to worry about graphing it, but so today let's just kind of look at what that looks like. Anytime you are asked to graph a function you don't know, I always tell you to make a table of values using my 5 favorite numbers, -2, -1, 0, 1, and 2. Okay, so if we were to put these 5 numbers into the basic 1 over x function, okay, so you'd have 1 over -2, which is just -1/2. 1 over -1, well, that would be -1. You have 1 over 0 for this one, which, if you remember the little Cookie Monster and Friends problem, you can't divide by 0. So this is actually undefined. This is one of those restrictions I was talking about. When you put 1 in, you just have 1 over 1, which is 1. And then for 2, you have 1 over 2, which is just 1/2. Okay, so if we come over here and we graph those, when x is equal to -2, f of x is equal to -1/2, which is approximately right there. And then -1, -1, that would put us at a point right there. And then all of a sudden we have this undefined value, so we don't really know what to do with that. So we look on the other side, you'd have 1, 1, so that goes there, and then 2 and 1/2 would go about right there. Well, if we fill this in a little bit further, what actually happens with the undefined point is that creates what is called a vertical asymptote. Okay, we actually are going to get infinitely close to that line, but we're never going to cross it. And the rest of this function, I'll just kind of spoil it for you. It is going to look like this. There's actually a horizontal asymptote on the x-axis here as well, because we're going to get infinitely close to that and not touch it. If you look at your graphing calculator, it gives you a better example of this. I've already programmed it into the calculator here, and this is what it looks like. Okay, this is a discontinuous function, meaning you can't draw it without picking up your pen or pencil. Okay, so that's what the basic function looks like. Now, with every other function we've talked about this year, there have been transformations on that function. Okay, we're going to be moving this function, we're going to be stretching it, compressing it, all sorts of different stuff. Okay, so just like every other transformation with functions that we've talked about, the stretch or compression is when we multiply the function by some value a. Now, typically, that a is going to be in the numerator. Okay, so if you have anything other than a 1 in the numerator, that means that you're going to have some sort of stretch or compression. Now, if a is bigger than 1, it's a stretch. If a is between 0 and 1, it's a compression. Just a little note on compressions. You could have a number in the denominator being multiplied by x, and if you think about it as a fraction, then a would be between 0 and 1, so that would be a compression. Spoiler alert, you'll see that later. Okay, if we are moving the function left or right, that happens in the denominator. Okay, inside the function, remember? And it's always opposite what's inside. So if you have something down here in the denominator, some number that you're adding or subtracting to the x, that's moving the function left or right. So again, inside the function, okay, so inside the denominator, and it goes the opposite way. Okay, we've seen this before. If we're adding or subtracting something to the function outside the 1 over x, okay, so maybe at the end here. okay, some value outside the actual fraction, that's going to move it up or down. And again, you follow the sign when you are moving up or down. And then finally, for a reflection, if the fraction is negative, it's going to reflect it. Essentially, this little branch is going to be up here. This branch is going to be down here. It's just going to flip. Okay, so the negative sign. Okay, so all we are doing in this section is now identifying and describing the transformations. I'm still not even having you graph these yet. Okay, so look at these 4 problems. Try to describe the transformations right now. Go ahead and take a second, pause the video if you need to, try and guess them, because I'm about to go through them right now. Okay, the first one here, you have a 2. We talked about that. That's greater than 1, so this is a stretch of 2. And then this plus 3 is outside the fraction, so that means it's going up or down, and you follow the sign, so that means you would go up 3. On the second one, you have a negative, okay, so that means it's a reflection. And for all intents and purposes, we are talking a reflection over the x-axis. And then finally, you have a plus 2, but it's inside the fraction, so it's inside. That means it's moving left and right, and we go the opposite direction, so we would go left 2. On number 3 has a bunch of stuff going on. First of all, you see the 0.25. That's between 0 and 1, so that's a fraction, so that's a compression of 1/4, because 0.25 is 1/4. Don't be afraid of fractions. Minus 3 inside the function. That means we're going to go the opposite way. We're going to go right 3. And then finally, you see the minus 1 on the outside of the fraction. We follow that. That's down 1. And finally, on the last one here, this one's the most difficult one of them all because it looks different. Okay, first of all, this 2, what is this 2 doing here? Well, it's not being multiplied by the fraction. We're actually, the 2 is a positive 2. This 2 right here is actually up 2. I'm going to write that at the bottom. Okay, so that's actually no different than if we were to move this plus 2 to the end. All right, addition is commutative. It doesn't matter, but we're not multiplying it, so it's not a stretch. Okay, the fraction itself is negative. You see the negative in front of the fraction. That's a reflection. Okay, so this is actually being reflected over the x-axis. And then finally, we see this 1/4. I told you if you have a number in the denominator which creates a fraction less than 1, that is actually a compression of 1/4. So these 2 actually, this 0.25 in the numerator or the 1/4 in the denominator, I guess the 4 in the denominator, they mean the same thing.